on the track, which number or numbers do you want to see? Do you go over, have questions about 2 and 4, 4 and 5, 3, 2 and 4, 1 and 2, 2, 3, 4. I think I got someone with each. So we'll do one, all of them. Some can be done on desmos, some cannot. The first one, is this a positive, negative, 0, or undefined slope? Positive. This is going up and to the right or down and to the left. And then you have to calculate it starting at either point. You can count up 1, 2, 3, 4, 5, 6, 7, 8, and to the right 3. So your slope should have been 8 over 3. Using desmos here would have been more work, more time, because you would have to put in both points and then count the slope that way, which can be done, but you were doing the graph, so not necessary. If you know or remember what parallel and perpendicular slopes look like, you don't need desmos. As a refresher, parallel slopes need to be exactly the same. These are not the same, so it can't be parallel. Perpendicular has to be negative reciprocals, so same numbers, but take it, flip it. If it's negative, it has to be positive, and vice versa. So it is perpendicular. If you were looking at them on a graph, so if you put them into desmos, they would also have to cross and make a T. They do that here. So that would also tell you it's perpendicular. The number 3 asked how many solutions does this have. So all of your equations and inequalities can be done in desmos. You can put this in and see if you get a line or not. If you get a line, that's one solution at 1. If you put in this and you don't see anything, you'd have to put in each side separately, and they would either overlap, being infinitely many, or you would get parallel lines, and that would be no solution. Questions on any of those 3? As we've been doing this, I've been saying every time you see write an equation, you should be trying to do this in desmos. So we have our point, we have our equation, we know it needs to be perpendicular through. So write an equation, type in your y equals x plus b. It'll have you put in sliders. I just have the slider going right now. Put in the equation and point that it has to go through and be perpendicular to. If it's perpendicular to this, the slope has to be flipped. So now 4/3 and negative since it was positive. And then it has to go through that point. So at 1, it would go through that point. So the equation would be y equals negative 4 over 3x plus 1. 4. Then 5, it asks you to graph the inequality. So if you were using desmos, you didn't need to solve it, but if you weren't, you did need to solve it. You should have had a dashed line, y-intercept at -3, slope of 1, positive 1, shaded below. So if yours does not look like that, make sure you fix it. Do we have any questions on those last two? So if you have desmos, you can leave it out, because today we're doing quadratic regression. So I'm going to show you how to do it on the calculator and on desmos, and you can choose which you like better. On the test that you'll take, you'll have the option to do either or, like you did for line of best fit. For the SOL, you'll only have desmos, so you'll need to know how to use desmos. We're going to start off on the calculator and then do them in desmos. Go ahead and reset your calculator, second plus 712. What's nice about this, the quadratic regression, is very similar to linear regression or the line of best fit, curve of best fit. They're the same. They're similar. So the steps are really similar. So after you reset your calculator, you're going to go into stat next to the arrows. And you're going to go into edit by hitting 1 or enter. Remember that all of your steps are on your notes if you get lost. Then you have a table on your notes. You're going to put the x values into L1 and the y values into L2. You can do so by putting in the number and hitting enter, or scrolling down and putting in the number, either or. Once you have all of your numbers in there, the next part is really the same as if you were finding line of best fit. Ignore this table in the middle of your notes that is from a previous thing. So you're going to go back to stat, scroll over to calculate, but we're no longer doing linear regression, because that was 4. We're now doing quadratic regression, so that's 5. So we're going to number 5. Just as before, if we want to store it in the calculator, we go down to store regression equation, hit alpha trace, and enter 3 times. And it'll now give you 3 things instead of just 2, because there's an A, a B, and a C, which we should recognize from our quadratic equation, which should look like this. So we're going to take those numbers and put it in the equation for our curve of best fit. So y equals, you can put negative 1x squared or just negative x squared, either or, doesn't matter. There is no b, or the b is 0, so there's no bx term. Questions on any of that before we do the prediction part? Just like with the line of best fit or the linear regression, to predict a y value when given x values, we're going to store these values as x values. So I'm going to hit 3. And then the STO above on. And then x, and then enter. And then now that 3 is stored for x, I'm going to go back and grab my equation, alpha trace. Wherever you stored it, hit enter or that number, and then enter once more. So y equals negative 2. We're going to do that one more time for the 4. So if x is now 4, same thing, type in 4, hit the STO button above on, hit x, and enter. And then grab your equation from alpha trace, and hit enter twice. So when x is 4, y is negative 9. Can you hit new session? Do we have any questions on how to use the calculator for quadratic regression so far? We're going to do that same problem, but now in desmos. So in desmos, just like your line of best fit, you're going to go to the plus and add in the tables. In your table, you're going to add those same values we just used, so the table from up here, put those values in. If you're typing, if you start to hit enter after like the second one, it'll recognize the pattern, so you don't have to type in each one. Only for the x's, though, you still have to type in your y's. If your graph is zoomed in or zoomed out, you can always hit the magnifying glass so it looks more centered. You'll see that it is kind of making that U shape that we've been talking about, that quadratic. And then to write our curve of best fit or our quadratic regression, we have to know what the equation is. So kind of like our line of best fit, the y equals mx plus b, it's going to look similar to the quadratic equation, but different as well. Whatever numbers from your table are, the x1 and the y1, that's what you're going to use. So y1. And this equation is on your paper if you need to find this or see what it looks like. And then the squiggly line, the tilde, which is in your keyboard, or you can type it if you hit Shift and then the button above Tab on the left. A, x, 1, and then squared. So x1, and then make it squared. If you make it squared first, it'll do weird things. And then plus bx1. Plus c. So it'll also give you that A, B, and C value and your curve of best fit. If you wanted to put that in all together, you can put that in the next line. Overlap. And if you wanted to find where a certain y value was when x values were whatever, you could type in x equals 3, see where those intersect or overlap, and then write that answer. What questions do we have about how to put this in desmos so far? This happened earlier. Instead of getting 0 here, someone got like decimals, 1 point something times 10 to the negative 16. That really just means there's so many zeros in front of the decimals, it's basically 0. It's 0. So if you get something like that, just assume that's 0. Last thing that we're going to do for lunch is write these two equations. So you'll need to know the difference between these two and the equations between them. Because that will help you find the line of best fit or the curve of best fit, depending on what the question is asking. when we get back from, alright, let's continue. So we're gonna draw or graph the points from number 1 onto the graph. So go ahead and start doing that. As you are looking at the graph, does this look linear or quadratic? Linear, it's a line. So even if you didn't graph that to figure that out, you could also look at your table. Your x values are going up, your y values are also going up. That should tell you either way this is going to be a linear function. But our goal is to focus on the quadratics. So it is linear, but we're not going to find the equation for that one. We have talked about how to find it in the past, though, so you could. Go ahead and graph the points for the second one. Is this one linear or quadratic? Quadratic. It makes the U shape so you can clearly see that. In the table, how you would know that is your x values start to go up, but your y values either go up and then come down or go down and then come up. It does one of those things. In this case, it starts to go down and then goes right up. So then we're going to find the curve of best fit for this one. I'm going to use the calculator for this one and Desmos for the next one. You can choose which one you want to do. If you're doing it in the calculator, go into Stat, Edit, go up to the top and clear it out. Clear, not delete. And then scroll down and it'll get rid of everything. Do the same thing for the other one. And you can put your points in there. Go all the way up to the top and hit clear, and then scroll down. If you're in the calculator, you're going to go back to Stat, scroll over to Calculate, down to number 5 or hit 5. In this case, we don't need values, or we're not predicting values, so we don't need to store it, so we can just go down and calculate it. Whether on Desmos or on the calculator, you should have gotten these same points. So our equation would be y equals 1x squared, or just x squared, plus 2x minus 1. Do we have any questions on how to find the curve of best fit in the calculator? We're going to do the next one in desmos. So number 3, if I'm looking at this table, the x values keep moving forward, the y values go up, but then go back down. So that's going to tell us this is quadratic. So we can go ahead and plot those points. Should look something like that. That would also tell you it's quadratic. So then in desmos, we're going to put these in the table. I'm going to use the same table I already had. If you want to get rid of yours and make a new one, you can do that. Or you can just change the values of the same table that was already there. Your choice. So I already had my equation there. If you got rid of yours and added in a new table, you'll have to change this to y2, x2, and x2, or whatever numbers your table says. So then our equation using those 3 numbers would be negative y equals negative x squared plus 6x minus 10. Do we have any questions on how to find the curve of best fit on desmos? We're going to do a word problem. So you'll need to be able to tell the difference between different sets of data if it doesn't say specifically line of best fit or curve of best fit. If it tells you something with years, years is a linear thing, 1 year after the next it happens. So this will always be linear, so you would be finding the line of best fit, your y equals mx plus b. Anything else you may have to think about, how would this look? So if a coin is thrown off the top of the center movie, so if I'm standing up there, which I would never because I'm afraid of heights, but if I was up there and I tossed a coin off of it, it would go up first and then come down. And that shape of it coming up and then going down would make that U. And that would make this quadratic. And then we can use the numbers given to find our equation. So, do we want to use desmos or the calculator? Desmos. So I'm going to use the same table I already had and just change my values. you may have to hit the magnifying glass. That way it zooms out because the numbers are big in the 300s, almost 400s. Your equation is y equals negative 16x squared plus 78x plus 305. Then we have to find, so it doesn't just ask us to find the equation, it also asks us to find the height of the coin after 7 seconds. So t represents the number of seconds, and that looks like your x. So we're looking for when x is 7. So in desmos, I'm going to make this x equals 7. And look at where those two intersect. $67 feet, yes, feet, would be our answer. Because they're really far out. Do we have any questions on how to use our curve of best fit to predict? There are other word problems on the back. Quadratic ones 6 and 7. Did we want to see either of those? Melissa. 8's going to be linear because it's dealing with years, so we're going to go do that one. So between 6 or 7, we can do 6. 7, you know, is going to be quadratic because it's showing that U shape. 6, you have to think about a football. If it's kicked into the air, gravity makes it come down eventually. So it's going to make that U shape. It might not look like it exactly, but it will eventually make that U shape. So this will be quadratic. Okay. Try again. Do we want to do this one in Desmos or calculator? I heard Desmos before the calculator, but you can still do it in the calculator. So your quadratic should look something like that. If you have multiple up on your screen, if you're using Desmos, you might want to get rid of some of them. That way you're not confused. Use the magnifying glass that pops up. I just did mine, that's why it's not there. To zoom in. Your equation for that one is y equals negative 16x plus 82. I'm sorry, x squared plus 82x. There is no c, so nothing there. And then we're looking for the height of the football after 5 seconds. So again, we're looking for the y value when x is 5. So find where those intersect. 10 would be the answer, 10 feet. Any desmos or calculator questions? Take out your testnav packet. We're going to go through all the ones you should have done up to this point, and then you'll have time to work on the remaining. Anyone need another one of those? Go grab one from that top. Anyone else that needs another one? There's extras on the top of that crate. Okay. You have your computer, you should have Desmos open. That way you can be trying these tricks if you didn't do them the first time. First thing that you may have noticed is this formula sheet. As far as I know, you'll be given the same one. In the SOL, like on the computer. That's what I was trying to say, not like an actual piece of paper. You won't really need these except if you get like a word problem where you have to use area or perimeter and you need to be reminded, those will be there. Right. For whichever ones I can show you how to use Desmos for, I'm going to show you those along with the answer. So number one, you could put in everything with all of the symbols and math operations, and it will tell you the answer. So 35 was the answer, or what was it, C? B. Questions on how to put any of that in Desmos? Two. So I changed the variables. Let's say if you forget, it's not working for you and you forget, you could change the variables to something A to E, or you could just make these capital X's and it would work the same. It's going to ask you for sliders, to add in sliders, hit that, change the slider to something positive, and then put in all your answer choices and look for which one matches, which should be this last one, which was D. So all of your exponent things you should be able to use Desmos for, especially if it's multiple choice. If it's not, you could always check it with Desmos. Questions on that one? Three is a quotient problem. So quotient, we're dividing. You can put that entire thing in all at once. I'm going to put all of these in at first. And then look and see which one overlaps. So this was the original. There we go. Okay. So this was the original. And then as you start to graph these, look and see which one overlaps the one that was already there. That one does not. That one does not. That one is a line, but it doesn't overlap, so it has to be 5x minus 6, or D. Let's try this again. 0, 9, 2, 8, 6. All of the problems can be done by hand as long as you remember how to do it, but you could also use Desmos if you remember these tricks. As we're going through them, I would, if you didn't do this already or didn't do this process, write yourself a little note so you remember how to do this when you're going back to practice. Look for overlapping for this one. Capitalize the variables for the last one. Put in all the answer choices. See which one matches. Look for overlap. Things like that. Hints and notes for yourself. For number 4, if you were finding the factors by hand, you could use desmos to check yourself. The first 2, this should have been 9, not -6 like I did earlier. The first 2 don't really help you much because they don't overlap or anything. So of those 2, you would have to look and see which one could I divide each of these by. 9 wouldn't work, but 3 would work, so that would be one of your answers. The other factors, you have to look and see which one overlaps, and I know the answers are shown already. These 2 would not be answers because they're not in simplest factor form. I could divide both of these by 3, so it's not prime. Same thing here. With these 2, only one of them can be the answer. Whichever one crosses the original at the x value, x-axis, that would be your answer. So 3x plus 2. And then same thing with the next 2. Both of these can't be the answer, but whichever one goes through the original at the x-axis would be your answer. So those 2 and 3 would be your 3 factors. Do you have questions on any of those so far? Okay. 5, similar to the exponents, I changed the variables, but you could leave them the same as long as you remember to capitalize. If you don't remember that, you could change them to whatever you want. If you have multiple in there, they won't work unless you change the letters. That's why mine are I and L instead of whatever I had before. Change them to positive things because it might mess up if they're negative. And what's going to happen is there's going to be 2 that match. The 5. And you have to look and see which one is more simplified. So 20 has factors. It can be broken down to 4 and 5, 10 and 2, 1 and 20. Because it has multiple factors, that would not be your answer. 5 can only be broken down to 1 and 5, so that would be your answer. D. Questions on that one? Six is the same, but this one was just numbers. So if you put in that original, one of these has to match. I'm sorry, 2 might match. Whichever is the more simplified of the 2. We can't break 2 down more except for 2 and 1. 16, we have 4 and 4, 8 and 2, so that wouldn't work. So 12 times the cube root of 2, or C, would be your answer. Seven, you kind of have to put the answer choices into the problem to figure out which one works. So we know it should simplify to be this. So if you start putting the answer choices in and see which one matches, that would help. So the one that matched was the cube root of 875, or C. You're taking the outside things, multiplying them together, and the inside things and multiplying them together. The answer you get should match decimal-wise. If you didn't remember that, you could start putting in numbers and seeing do they match or not. That might be time-consuming, but I don't think you really have a time limit. So you have time to play around with it, but if you know how to do it, it would make it go a little faster. Questions on any of those? Nine is something you have to know. You have to know that if you get something that's 1 equals 2, that's no solution. Ten is something you can put in desmos. We just talked about this either last class, the class before that, or last week. So you have some quadratic. You can put that in, see where does it cross the x-axis. It's going to give you those 2 points. The problem had fractions instead of decimals. You can put those fractions or decimals in and change it and see if they're the same. If they are, that would be your answer. So C was the answer to that one. As I mentioned earlier, all of your equations and inequalities can be done on desmos. So if you type in all of this, it's gonna shade whatever the answer is for you. This is a dashed line, so it has to be less than or greater than. It's shaded to the right, everything above this number, so it has to be greater than whatever. And then look and see where does it cross the x-axis. So in that box, you would type in x is greater than -9. So as long as you know how to read this answer, you can use desmos to solve it. Is similar, but it asks you to select which of the rays is the correct one and put it at the correct location. So if you put this in, it'll tell you what direction you're going to go. So it's dotted line, so it has to be less than or greater than. It's shaded to the left, so everything below, so it has to be less than. So that would be your open circle pointing to the left. And you would put that at -4. And when you go to do that, it would graph a line for you. Questions on 11 or 12? Was x is greater than -9. Is that? You can make it fast. Okay, for 13, because it's a word problem, you would have to know how to set up the inequality. It gives you these numbers, 750 per hour, 1250 per hour, at different times, night and day. He wants to earn at least 300, so he could earn 300, but if he earns more, he's not going to be mad about it. So that would be 7.5x plus 12.5y is greater than or equal to 300. And if you graph that, it would look something like this. And how we know what the answer is, look at the type of line and where these intersect the x and y axis. So C would be your answer. Questions on that? 14 has the system graphed for you, but not shaded. And it's asking, basically, where do they overlap? So the section they overlap would be this one, which I think is 2. Yeah. So when you click 2, it would shade in that area for you. 15, they give you two inequalities, and you have to determine which sign is which. So with the first one, it tells you your y-intercept is 2, your slope is negative 1/2. Look at which of the lines fit that description. And that happens to be the solid line, so it has to be either less than or equal to, greater than or equal to. And then look at the shading, and the shading is above that, so it would have to be greater than or equal to. And then for the other one, that has to be the dashed line. So it has to be either less than or greater than, but the format of it is weird, so you have to kind of rearrange it before you can determine which one it is. If you rearranged it, it would be less than, but here it's greater than, but this is the overlapping. That's how we know that one's right. Questions on 13, 14, or 15? This one's 15. So it's greater than or equal to and greater than. You don't really need Desmos 4, but you're welcome to use it if it helps you. If you know the vocab for it, shifted is anything dealing with the y-intercept. So if you're comparing the two y-intercepts, it was at 0, now it's at negative 1, so that would be shifted down. For the second one, it's talking about the slope. Slope is steepness. If you're comparing the slopes, it was 1, now it's 6. 6 is bigger than 1, so it is steeper. So Desmos will help you see that, but you'll have to know that stuff too. Same thing with 17, sorry. Because slope deals with steepness, that's going to be multiplication or division. So the slope was 1, now it's 1/2. So the answer to that one is 1/2. Because the y-intercept is a shifted up or down, it was at 0, now it's at 2, so it's been moved up 2. So it's 2 more than. So 1/2 and 2 more than are the answers for that one. You can use Desmos, but not at the same time. You have to know what the words mean, and really your plotting point, so it would just help you to see it on Desmos. Shifted up 2 means your y-intercept is going to go up 2, so now you have a point at 2, you could use that point. The slope is now 3 times as steep, so from that point you could use your slope or know that it's now 3. So you could use this line to help you make 2 points, but you'd have to know that's what you're looking for. Once you plot 2 points, it would graph a line for you. Do you have any questions on 16, 17, 18? Because it gives you an equation or a function, and it's asking what is the range, you could graph it, look at the lowest point, 3, and it keeps going up. You could zoom out to confirm that it keeps going up. So it would be everything greater than or equal to 3, so B. And then 20 and 21 are good Desmos problems. 20, you're looking for which of these has exactly 1 0. Remember, 0 is the same as solutions, x-intercepts. So which of these cross the x-axis only once? Purple does it twice. Black does it twice. Blue doesn't at all. So the green and the red, or these two. And then for 21, similar. Which of these has an x-intercept at 3? So the only ones that have an x-intercept at 3 are the red and the green one. Nothing else goes through that. So those two. Do we have any questions on 19, 20, or 21? For the remainder of class, you can work on testnav first. Try numbers 22 through 28. Use desmos with them. Some of them you may not be able to do, but try to use desmos to figure it out anyway. The ones you may not be able to do, we're going to talk about on Friday, so then you will be able to do them. After you finish 22 through 28, which is the rest of them, then you can work on concat me. Use this time wisely. You guys can